Hi, and welcome to learn about how a nuclear bomb works. I'm going to just kind of go through kind of the basics of what both of them, kind of some of the similarities between the two different types of uh, nuclear bombs that humans are capable of and use, or at least produce, and have used in the past. So we'll kind of just talk about the kind of the what they look like, and then I drew a picture just to kind of help myself understand it a little better, and we'll hopefully be able to kind of show you what happens. So with a nuclear bomb, these are what they do is that they are a force that is created through a nuclear reaction. So with this nuclear reaction, it is forced upon um, elements that then create a chain reaction. So these are built in to every atom. Every atom has energy that is stored and then can be used for that element's purpose. What happens is we have created, and some are naturally occurring, isotopes, which are different numbers of protons within a nucleus of an element, and it creates isotopes. Those isotopes, the basis of it can be stable, where they are at home. They don't make a bunch of, the energy doesn't leave that nucleus, and it's not thrown out into the world. With isotopes, though, that element in that nucleus is not stable. So then the energy expands and leaves. It does produce it produces things like radiation. Radiation decay can create things through kind of force like thermonuclear energy, and we'll talk about both of those things, about how they work into the two different types of bombs. So what I'm going to talk about first is the atomic bomb. The atomic bomb is best seen through like one of the bombs that was dropped on Japan during World War II. And what it does is it's the structure of the bomb really just looks like a big torpedo. So it is a chain reaction within the heavy nuclei to force this energy to be expanded. So what happens is that pretty much one of the protons is forced at the element, and then it begins to split it, and that causes nuclear fission. So nuclear fission is found through certain materials, and it's more readily available when it's through these elements. So those elements, like we said, they go through the isotopes. With the isotopes, they're contained at a more stable isotope, and then when you add that next proton to it, then it forces that to become unstable, and then it creates fission, because then one goes into it and then has to kick something else out because it's trying to reach equilibrium again, and then it just boom, 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 and it just keeps on going. So with that, in like atomic bombs, most of the time it is uranium, and it's uranium-235 because can be easily pushed to be unstable. Plutonium is also one of the other ones that can be used. It's plutonium-239. So one of the biggest parts of an atomic bomb, though, is that it needs to be, they need to be able to create critical mass. So that's what we're doing when we try to get these to not work through equilibrium anymore. So what we have to do is they normally use 4 to 5 of them, of these almost like containers of these of the elements and of these isotopes, to try and force that critical mass. So they use multiple of them, so it actually has more force. So with this, they're stable on their own, so we have to force the critical mass. So even though one of the protons is shot into it to then start that critical mass, it still has and I'll show you, this is where my drawing's going to come in handy, is you can kind of see it here. So right through here is let's just call it the core, and then you have multiple of these core, like we'll just call this another core as well, of these stable isotopes that are then, when you inject that first isotope into it to help it reach critical mass, it'll blow up. So as a cross section of this, these are what they look like if this was, say you just took a cut and you just cut it about like here, what you would see. So on this outside over here though, these are other reactive and explosive materials in here that then these explode, and the energy of these is pushed. So that would be like if they are around in this area out here, they force these together. So this is the core, and then each of these is the ones around it. And so then when we add that explosive material on the outside, so say in this area around, and force them together, we force it all together, and then it creates this critical mass here, and then that proton goes through and hits, and then it starts that chain reaction. So with that is pretty much how a atomic bomb works. So we're just really trying to force that critical mass to get it to explode. So with the other kind of nuclear bomb is a hydrogen bomb. Hydrogen bombs are used so far not really against human life intentionally. It's more used for testing, and it's been tested multiple times, but it's not so much really used, at least to my knowledge. I don't know if it's been used against humans in that way, such as it was in World War II. So the hydrogen bombs are a little different because they're a thermonuclear explosion. They are more like they're intensive heat, so they, instead of forcing critical mass, they actually use a detonation factor to then create the really hot and put out a lot of thermonuclear heat. So with that, there's a couple main substances that are used. So lithium hydrogen is used, and then deuterium and then tritium are both used. They use these because they are lithium is really easily found, deuterium is easily found in the ground, and then tritium is pretty easily found as well. So what these are is, I don't have a cross section of these at all because it's a little harder to draw, but the cone of the bomb once again has a reactive explosion that once it hits the ground or hits above wherever it wants to hit, it basically detonates, goes off, and then it starts a chain reaction of these elements to then increase the amount of reaction that goes through and creates thermonuclear heat. Instead of putting out going through a chain reaction and forcing it that way, it is able to just boom. So they're both very devastating. They both have a lot of problems that go along with them, but they're not always, it's not just the initial effect that really is the big cause or the big consequence of using these. The big one is of course there is destruction, and there's the instant effects that can go through and can be found, with even just the destruction, the heat, everything like that. Those are all, the initial part of it is a problem, but it's not the main concern. The biggest consequence is radiation. So the reason why that is both the hydrogen and the atomic bombs both produce radiation, and radiation decays through a half-life, and those are different based on what the material of the bomb is. But that radiation stays around. It soaks into the ground. Food, you can't really make food. There's no food that can be grown there. It can irradiate. When it radiates humans, it is devastating because it can cause mutations within humans. It can cause cancer. It can, everything is affected. It's not just the initial explosion of it. It permeates the ground. Like I said, you can't grow food. Everything you touch holds on to it. your body holds on to it. You know, even like there's still effects from Hiroshima and Nagasaki, those two bombs from World War II. Those both are. There's still people who, you know, are irradiated, and they're not. Some of them are dangerous. It's not a bomb, but like look at Chernobyl, where you still can't go into. Like Chernobyl's still kind of a lockdown site, even though that wasn't that long ago, because it is so radiation heavy still, because it takes so long for those materials to decay all the way to safe levels, and with the different kinds of radiation that is used between alpha, gamma, or alpha, beta, or gamma rays. You know, alpha is pretty normal, doesn't hurt us. Beta is more dangerous, and so you can't get nearly as close. But gamma rays, there's really not much protection for it. You know, even things like lead or anything like that can be pretty. You have to use thicker and thicker walls of lead depending upon how much radiation is put out. So, yeah, that's pretty much how these two bombs work, specific for any nuclear bombs, specifically the hydrogen, the atomic bombs. Hope you enjoyed it. It was interesting to kind of learn about. So, yeah, thank you.